we're going to do the last chapter, or last topic in this chapter, which is called measurement fractions, and also involves conversions. I like to call it dimensional analysis, and for those people who are doing chemistry, we'll see dimensional analysis in chemistry. And I'm quite glad that I have you first, because I'll give you a quick introduction to what it looks like before you get the real deal in chemistry. We're really going to use this kind of stuff. So you see what I did right here. The biggest concept that's most challenging to get your head around with measurements and fractions and conversions is something called, if you get your head around this, you'll be fine. Equivalence. Right? What I mean by that? Well, I'm just going to get that out of the way for a second. What I mean by that is that things that are equal, things that are the same. So, if I were to look down here, on this side of the ruler here, I have centimeters. Okay? On this side of the ruler, oops, my bad. Ooh, here we go. This side, we have inches. All right. So that means we have two ways to measure a distance. We can measure it in centimeters. We can measure it in inches. We can measure it in kilometers. We can measure it in miles. We can measure things a lot of different ways. And sometimes we need to compare the two distances or the two measurements. In order to compare the two measurements, what we really need to have is a common unit for comparison. Okay, so for example, if you're going to run on the Blue Nose Marathon and do 10 kilometers, how many miles is that? I don't know. But you can do it using this kind of thing. And before I get started in the actual doing it, I want to put more background into it as well, so you can see, hopefully, why this works. Because when I first saw this, I was like, what is going on there? I have no idea. So, again, a long introduction to this topic, because I think it needs it. So let's just see here. If I had two numbers that are equal, we know this. I'm going to use 7 is equal to 7. Right? This is the easiest way I can start the discussion. This is pretty simple, pretty basic. 7 is equal to 7. Because these two are equal, I can do this, right? 7 over 7 is 1. Right? Okay, we're all comfortable with that. So if I had another number here, this is where it gets kind of crazy. Another number down here, we could say I had 6. 6 divided by 1 equals, please say 6. Right? Now, that's all great. I love that. That's fine. But when I do this, everything goes crazy. When I go 6 times 7 over 7 equals, really? It equals 6. Because 7 over 7 equals 1. So what I'm trying to show you here, even though see, I told you it gets crazy really fast, right? So anyway, so it all looks good right to here, and then when you get to here, it's like, what just happened? They just changed the fractions in there. Oh my God. So anyway. Yeah, exactly. It's just same as 6 times 1. Same thing. But it looks really crazy now because of the fractions in there. I think it's because we were programmed to hate fractions since back in school days, that we can't get our head around that anymore, that 7 over 7 is simply just 1. Okay, let's just do this. Let's do this the hard way, the long way, just to prove it, okay? Prove that this is the right thing and the answer is fine. So let's just take this equation right here. We know the answer is 6, but let's do it out the hard way. So I have 6. Sometimes my pen acts up. 6 multiplied by 7 over 7. So we know that I can't multiply those because it's a whole number times a fraction. But because we're experts in numbers and fractions now, we know that I can rewrite this as 6 over 1. And I can multiply across. So 6 times 7 is 42. So my pen wants to cooperate. 42. 7 times 1 is 7. And then my 7 will divide back into 42 6 times. Okay? So this is kind of like, this is how it works. I shouldn't say. This is kind of how it works here mathematically. But using a sort of a shortcut up here, we know that 1 is 7 over 7. So we don't need to do the math behind it. And the reason why I'm doing this is because I want to get you used to seeing this thing right here. You're thinking, why did you do that? Because when we get into measurement, like as I mentioned a minute ago, there are different measurements that are the same. What? Well, let's go back up to the ruler, for example. If I were to take a line, it's going to make a line here. A little bit on draw straight lines. Kind of cheat a little though because I use this technology. So if I take this line here and I move it along this way and this way, you can see that if I were to stop here, for example, at 1 inch. Down here, you'll notice that it's 1 inch. But up here it gives me 2.5 centimeters. But the reason why I'm using this little black line is because whether I say it's an inch or I say it's 2.5 centimeters, it's the same distance. Nothing has changed except the units, how we measured it. Okay? We're all happy because now it's going to go, because the next step goes crazy. All right, we're good? All right, so, I'm just inserting the page. Yep. So, it's on test 2, yeah. So, what we just said, back here to the ruler for a second, we said the 2.5, actually the correct actual real number, because I know from chemistry, is 2.54, but we won't worry about that. But I see from my ruler, we just said 2.5, just for an average. So 2.5 and 1 are equal. Cool? All right. So that means that we have 2.5 centimeters equal to 1 inch. We're cool with that, okay, right? Uh-oh, what do I did this though? What's the value of this? 2.5 centimeters over 1 inch. Now, this is pushing it a bit, I know, but we said before, because these pieces up here are equal, if we put one over the other one, the value is going to be 1, right? Same as back here. We have 7 over 7, value is 1, because 7 is equal to 7. So 7 is equal to 7, 7 over 7 is 1. It looks funny here because it's these units and they don't make sense, but since these two pieces are equal, if I put them one on top of the other, the value is 1, because they're the same distance. And it doesn't matter which order I put them either. I can go like this as well. I can put them like this. I can go 1 over 2.5 centimeters. And that's also equal to 1. Cool? No, these are just equal to 1. Because the top here, let's go to the board that time. This piece here, up here, is equal to that piece there, so the answer is 1. Just 1, right? No. So, what about this? This just use some common sense first. Sometimes for common sense, it's not so common. But let's just, before we do any math behind it, we know that 1 inch is 2.5 centimeters. How many centimeters would be in 2 inches? Well, if 1 is 2.5, and I had 2 of those, how many centimeters would I have? Yeah, 5, right? Because if I have, let's just look at it this way. If I have 2 inches, that means that I have 2.5 and 2.5, oops, which gives me 5 centimeters in total, right? But there's an easier way to do this. Well, sort of easier. When you're used to it, it's easier. Instead of doing this kind of thing, because sometimes the numbers will get more complicated, and I'm using easy numbers now, so it's not so bad. But let's use it doing the, let's use these pieces up here now and have a look. Highlight these. Let's use this stuff here and find out how to convert. All right. So now, looking down here below, if I have two inches, and I want to go into centimeters. Remember when we did reducing? This is a little side note, I guess. And there's a little side note. I'll put it over here. We had something like 4/10, right? We know that that can be changed into 2 times 2 and 2 times 5, right? And the top and bottom are the same, we can cancel them out. We've seen that before, not a problem, right? That's going to be important as I bring this along, that's going to be important as well. So we're starting with 2 inches, but we want our answer to be in centimeters. So, looking back up here, we have these 2 pieces to choose from. The trick is that whatever we want our final answer to be in, the unit here must be on the top. Alright? So I'm going to use this fraction and multiply. Okay? I'll do this really slow. So now I'm going to multiply by 2.5 centimeters over 1 inch. Right? Now it doesn't change the value because we know that this piece right here is equal to 1. Okay? So we're not really changing anything. It's changing the units. So what happens, again, I'm going to, later on I'll do it more quickly, but right now I'm going to do it really, really slowly because it makes more sense. So now, this is going to be 2 inches over 1. See that? Multiplying them together, we're going to have 2 inches multiplied by 2.5 centimeters over 1 inch, or 1 times 1 inch is going to be 1 inch. You're like, what? So what? But what happens, like right here, when we cancel right here, the same thing happens down here. Now I have inch on the bottom and inch on the top, so the inches, the units, will cancel the same as the numbers do. Okay so far? Starting to get kind of spooky looking at there. It's like, no, I don't know where you're going now. But pretend that the units are the same as the numbers. Like up here, when I use, the 2 and 2 and cancel those out, pretend those 2 and 2's are the same as the units down here and they cancel out the same way. Now what am I left with? Okay, I'll just show you what I'm left with. What I'm left with is 2 times 2.5 centimeters. Now I do the multiplication, and I see it's 5 centimeters. So we just changed our inches into centimeters by using those conversion charts. Really? I'm so happy to hear that, because this usually takes about a week to go through. That's why it takes so much time and do it very slowly and prepare you, because this is, I never got this at all when I first time I saw this in university chemistry. Like, I'd see a big long equation across the book, and I'm like, I don't even know what that means. I'm going to turn the page. Yeah. Figure it out later. So now you'll see, like down here, you'll see what I mean. These are called common measurements and their equivalents. So you can see that 1 yard is 3 feet, 1 foot is 12 inches, 1 tablespoon is 3 teaspoons, and so on. All right. I'm going to change these to order of these. I don't like the order. So now, these charts, if you use them long enough, you get to memorize them. But the point I'm trying to show you guys is that, like, I don't want you to memorize the chart because you look it up or whatever, but I want you to know how to use this chart in the event that you have to use it. So let's just say, right here, check this one out. This one will be an example that you might find in nursing, for example. Your IV bags come in 1 quart. It's actually 1 liter now, but it used to be 1 quart years ago. So now, if you're there and you have to give, give 2 pints. How much do you give them? How much do you give the patient? How much of the bag do you give the patient? The whole bag? Because 1 bag is 1 quart is 2 pints. If you want to give the patient 2 pints, you're going to give them the whole bag? Okay, hang on. Yeah, you're right, actually. I was thinking something different. So they're equal. So how about you want to do this? Question's going to be number 1. Give patient 1 pint. Now, again, the number should make sense, and half a bag. Exactly right. But let's do it mathematically now. So now you know the answer, and it makes sense because the 2 pints is one bag, 1 pint is half a bag. It makes sense. But let's use our equivalent statement. So we're starting off with 1 pint. We want to end up with quarts. So how do we set this up? I got this equation up here. This is all I know. But we know that if we want to end up with quarts, then this has to be on top. So it's going to be 1 QT over 2. Everyone's okay with that? And then doing it more quickly, this one will cancel with this one. I'm left with 1 over 2 quarts. And that's converting. Sometimes you'll see a table that looks like this, but I don't really like these kind of tables because it says to convert from, let's see, from gallons to quart multiplied by 4, quarts to cups multiplied by 4. It's like, so like, this is not my favorite way of doing it, because oftentimes it's not the most accurate either, but you do see charts like that from time to time. But like, you gotta remember that if you want to go backwards from quarts to gallons, you divide by 4 and multiply. So it's kind of confusing. I like these charts back here, this type back here, because you can go either way. Sorry? It's easier to follow, for sure. Are we fine with that? Let's try a couple of examples from the book. If you need it, I'll provide it. I'm not going to make you memorize it. I don't memorize. I don't remember. I don't remember the last time I used pints and quarts anyway. It's like, what's a liquor store?
That's what I was thinking of when you were like, I was thinking, that's what I got.
You guys are worse than me. You know, half the way I teach math is using liquor store examples. You know that, right? So, anyway, it's pretty. I used to teach fractions by talking about a case of beer, and we went 2 people. How much would you pay for 6 beer? Right? So anyway, exactly. Fractions are realistic things, right? So, this one here. Yeah. No problem. I'm going to put these on YouTube anyway. And I'll put these on the site as well. So, let's go to our book. Let's try this one. Let's do the first one, I guess. I'm sorry, I'm just thinking of something else. Lost my train of thought for a second. It's funny, like, just jump on scaring people, right? I've been doing, like, martial arts for, like, 16 years or so, right? So I've been training in karate and harness man and a couple of different styles of things. So one of the things you've learned to do over time is learn how to walk a certain way. So not even on purpose anymore. When I walk, I don't make any noise. Basically, it's kind of, you know, the old kind of ninja thing, right? So this is on being recorded. I can't believe it. This morning I'm making breakfast and I was upstairs for a second, just getting my son up. Came downstairs and my wife was in the fridge and I just walked behind her and I go to the stove and I moved the frying pan and she's like, I just walked right behind her. She didn't even know I was there, right? I was like, I didn't mean to scare you, but sorry, my bad. Yeah, exactly. Too funny. So this is a perfect example here of what I'm talking about. In this case here, we're looking at 3.5 gallons and we want to know how many quarts that is. So our conversion factor, or I like to call it the equivalence statement, is right here. Gallons, quarts. So if I have this equivalent statement, I'm going to pop down here just to reinforce this concept. If I have 1 gallon equal 4 this is what you buy liquor when you go to the US, right? Because you can't afford it in Canada. So anyway. Yeah, exactly. Yeah, I know, it's crazy. So we can write this 2 ways. We can write it 1 gallon over 4 quarts, or we can write it 4 quarts over 1 gallon. And they both mean the same thing. They're both equal to 1, right? So we have over here, we're starting out on these different colors. We have 1 over 2 gallons. How are we going to convert that into quarts? Which one of these are we going to use? first one or the second one? If we want the answer in quarts, we take the one with the quart on top. Make sense? So then we multiply by 4 over 1 gallon. Now all our stuff we learned up to this date comes into play as well, because now we've got to multiply mixed number by a whole number. So let's get away from that by turning the mixed number back into improper fraction. Remember how to do that? 2 times 3 plus 1. So I have 7 over 2 gallons multiplied by 4 quarts over 1 gallon. Now again, notice gallon on top, gallon on bottom, they cancel out. So then I have, oh, you notice the way I do things. I always work down the page. I'm sorry, I never go across the page. No, that happens sometimes in some schools. The teacher go across. That's bad. Don't do that. So I have 7 times 4 gives me 28. Quart stays because it's the same, and 2 times 1 gives me 2. Gallons unit cancelled, and 28 divided by 2 gives me 14 quarts. And does the number make sense? Let's see. Well, if 1 gallon is 4 quarts, whoops. If 1 gallon is 4 quarts, then 3 gallons got to be a lot more. So it kind of makes sense. Whoa. Put on the brakes, slow down. Where did you go with that? Oh, remember way back in the day, last week, we used to do this. We would go converting, we would go 2 times 3 plus 1. Yeah. Just change the mixed number back into improper fraction. You could multiply 3.5 by 4, but multiplying by the fraction, I find it more complicated than you need to. But if you want to see it, it looks like this. No, I don't want to show it to you. So, how's that feeling? Pretty good? Yeah, maybe. Alright, let's try one more. I'm going to do some of the easier ones, just keep the numbers small for now. So let's try number 2. So, if I have 4 1/4 cups, how many pints do I have? Well, what relationship am I going to use? Is there a connection between cups and pints? Things work great, by the way. This board's working great. See what I'm doing? I'm doing the Miracast thing in here. So it's working great.
Awesome. So you did your wrap up. Car keys are in this jacket.
No worries,
I
man.
had it back there.
You can tell the boys that I think it was Randy was working on that. So
Okay.
perfect.
It's working good.
Working good.
I'll let him know.
Thanks. So going from cups to pints. Now, before I do this, I'll tell you another funny story. I'm full of stories today. I'm sure you've heard the term, watch your P's and Q's, right? And we tend to think of it as sort of behavior or language or whatever, watch your P's. Do you know where the term watch your P's and Q's comes from? It's a little interesting thing. Back in the old English days, when they had the public houses or the ale houses, where people would go and have their beer and things, quite often back in the day, even today, if you're on the dome, a fight breaks out. Exactly. Watch your pints and quarts, because there's a brawl going on. Watch your P's and Q's, watch your pints and quarts. And that's where it comes from. That's pretty neat, eh? So you're right at the ball with that one. You were good. So let's just take this. So our equivalent statement is going to be right. Most informative math class ever. 1 pint is 2 cups. So our equivalent statement is right here. And over here, I'm going to write down the equation. So I have 1 over 4 cups multiplied by, how am I going to set this up? Pint on top or cup on top? What my answer in pints? It goes on top, exactly. So I have 1 pint over 2 cups. And you see the cups will cancel because one on top, one on the bottom. Continuing on with the math, I'm going to take this one now and convert it into an improper fraction. So 4 times 4 gives me 16, plus 1 gives me 17. You see that? Multiplying, I'm going to get 17 pints over 8. 2 times 4 is 8, right? And then converting it back to an improper or mixed number, 8 goes into 17 twice, and 1 left over. Go back to this point here. Yeah. Remember that back in the day, last week sometime, people don't like to see larger numbers than the top. So we always go back to the mixed number. Yeah.